Hello everyone, my name is Jirka, this is Henry and Michael, and together we are part of Group Alpha, and our project was doing an air quality radar for Microsoft. So first of all, just a show of hands, who's ever seen a headline like one of these? So yeah, air pollution is a really big problem nowadays, and that's why Microsoft came to us and asked us to design an app which would predict and show air quality in Cambridge. And in particular, this was done using machine learning, and in particular, Microsoft Azure, Microsoft platform. So apart from understanding the task we were faced with, it was also really important for us to understand the motivation that our client had behind it. And this was, apart from air quality, this was also to do with showing the usefulness of publicly available data when combined with Microsoft Azure. And what this meant for us was that, well, obviously we only could use free publicly available data, but also that we decided to make sure that our code is really well documented and make it open source as well, so that people could potentially see how we used it and make use of Azure as well.
So we wanted the app to be useful for commuters, parents, people with respiratory problems, but then also city planners and businesses on a kind of larger scale. And we are hoping it could be expanded either geographically or in terms of long-term predictions in order to make it even more useful for all of these people. And we used all of our data was publicly accessible. And so, for example, stuff like the Met Office, they had an API that we used. And when looking at this data, we found that it was available for across the whole of the UK. So expanding it geographically outside of Cambridge is definitely a possibility. And so this is what the application would look like in your browser, for example. And so we overlaid the air quality data over Google Maps. And it's also to note that this is just the front end, and we also have an API that could retrieve you air quality data or weather data as well for research purposes or something like that.
Okay, so this was the application, but how we actually achieved it. So the design consists of three main parts. So there's the Azure platform, which takes care of data collection and machine learning, and then it sort of puts the data into Azure tables. So we have tables with historical data and predictions, and then we have a Java backend, which takes the data from the tables, changes the format a bit, and forwards it to the front end, which was written in Angular, and the front end is then the web application that you've just seen.
And in machine learning, we used Microsoft Azure Machine Learning Studio. And here we shows one of our experiments, which trains the day prediction model. And then each branch here actually represents a model which trained for predicting one of the pollutants. And we also implemented other models like neural networks and linear regression, but we chose to use boosted decision tree regression because it gives us the best performance. We also implemented time series analysis, and here on the left it shows the prediction error against time, and on the right is the histogram of prediction data. We noticed that this model captures the variations of air quality throughout the day, but it's very easy to miss some of the peaks, further into the future.
So in terms of some lessons we've learned from this project, first of all, as I mentioned before, it was really important for us to learn not only what our client has asked us to do, but actually kind of their intention behind it, which allowed us to actually fulfill all the requirements and make the extra effort. A second lesson we've learned was not to trust random web APIs, where we've spent a significant amount of our time trying to fetch data from a particular API. And when we finally achieved it, we learned that the data was completely inconsistent, and if you made a different query for the same data, you would get different results. So we couldn't use this data in the end. So that was a big lesson.
Yeah, in machine learning, we noticed that more learning data does not always lead to better models. In particular, in the beginning, we tried to put in all available data and features into the training stage, which gives us actually a worse performing model. One reason for that is that it couldn't identify the correct key features because of the noises, and yes.
Okay, so that's it. The website is hosted at airqualityradar.azurewebsites.net, and all the code is publicly available on GitHub. Thank you very much.